Okay, so transient or variable properties, which can change with time, um, are a bit of an issue. And moving on, um, contaminants. Originally, by the way, when I realized that there were different types of properties, intrinsic, test method specific, indicative, I had lumped transient or variable properties with contaminants. A colleague of mine suggested separating them out. Dirt and water, particles, and microbial contamination. So at this point, I've got them separated out. And contaminants, the ones that we're most familiar with, dirt and water, and microbial contamination. Dirt or particulates and water contamination often change during distribution. One example I'll use, which is ongoing all the time, a lot of fuel in the US is produced in refineries down at the southern end of the states, the Gulf Coast states, and fuel coming out of most refineries is quite warm and saturated with water. It goes into pipelines and gets shipped up to the Northeast states, the Midwest states, cooling all the way. And water separates out all the way along. This is normal, standard situation, and pipelines and receiving terminals have developed housekeeping practices to allow fuel to settle, for the water to drop out and be drained off. So contaminants change with time, and good housekeeping practices control or mitigate the problems. Now, microbial contamination. More of a problem in warm, humid climates. In Canada, where a lot of the country is cool and dry for 6 to 8 months of the year, we have very few microbial contamination problems. But warm, humid areas can have significant problems. The bottom line for microbial contamination is keep the fuel dry. One of the things I learned years ago in the field was that going back 30 and 40 years, people considered that an underground storage tank at a service station was dry if it had less than half an inch of water in it. Well, got news for you. Half an inch of water is a huge ocean to a microbe. A tank with half an inch of water is a wet tank, and microbes will happily grow in it. Dry means dry. Occasionally, there's unintended or unusual contaminants, soluble or immiscible. These don't occur very often, but sometimes they do turn up. And the precision of test methods is definitely affected by these transient, variable, or contaminant materials. If you're trying to measure the haze in a fuel, you can't store the fuel for a period of time, warm it up, cool it down, the haze will disappear. Haze is a test that has to be done on the fuel at the conditions of delivery. Most customers do not want to receive hazy fuel. Now, you can make the haze disappear by warming the fuel up, but as far as the customer is concerned, if the fuel is hazy, it's not acceptable. So when we develop precision of a test method for haze, it has to be done at the temperature of the fuel. And I'm going to talk more about precision of these test methods in a few minutes. Yes, okay. Okay, so I've put together on this slide all of the 5 types: intrinsic properties, test method specific properties, indicative properties, transient or variable properties, and contaminants. Do we have questions or comments? I invite you to speak up and pass any comments on this that occur to you. You have to unmute yourself to speak up, by the way. Is this clear? Do you see the difference between properties and their respective test methods?
Andy, Alistair Clark here. I have a question for you.
Yes.
Thank you. The transient properties, when we seek to develop a test method for the transient properties, that's particularly difficult with respect to precision because the laboratories. Any thoughts on that aspect, please? Thank you.
Yes, I'm going to be talking about developing precision at a single location very shortly. You fingered exactly the issue. So I'm going to come to that in a slide or two. Thank you.
Super, thank you.
Any other comments? I think Alistair wanted to get his crack in because yesterday I made a comment during his webinar.
Andy, Dan here.
Yes,
I find
Dan.
it interesting that aromatics is a test method specific property, but I guess it is. Even EPA calls benzene and gasoline a test method specific property.
Okay, what I was getting at when I listed aromatics is some test methods consider that if there's a single benzene ring or more, the whole molecule is called aromatic. Other test methods, particularly I think it's carbon-14, look at the environment of each carbon, and only the carbons that are in a benzene ring are considered to be aromatic carbons. And if you have an aliphatic side chain on a benzene ring, the aliphatic side chain is identified as aliphatics. So that's what I was getting at when I added aromatics to the test method specific properties. It's how the aromatics are defined. Are they just carbons in a benzene ring or a conjugated ring? Or if a molecule has one benzene ring or more, the whole molecule is considered aromatic. And this does give different results. Is that clear?
Yep, got it. Thanks.
Andy, Melanie did have her hand up. She may have had her question answered.
No, I was just going to comment on your relationship with drawing correlations. The other and related to that, your comment how we have lost experience as we've made things easier. The other thing that I have come across is our predilection to draw a conclusion, transfer it to the next test method, to the next test method, to the next test method. So the correlation ends up being 3 test methods away.
Thank you. Couple of comments I'm going to make, and they relate to my experience many years ago. I had the opportunity to set up an analytical laboratory in a research group that was looking at upgrading heavy oil to make useful products. And while I was setting up the analytical group, I was hiring both BSc chemists and technologists. Now, in Canada, a lot of our technologists have 2 or 3 year degrees. And what I found was that after these individuals ran standard test methods a few times, the BSc chemists would jump up and down and say, I can make a better test. They could improve the test methods. Unfortunately, when you change a lot of these test methods, you change the results, and they're no longer valid test results. The technologists would follow the procedure exactly as written. So they produced the valid results, which were what we were looking for, and we could compare the results to other programs. So I quickly realized that I had to put technologists into running the standard test methods, mostly ASTM test methods. But when it came to developing new test methods to support the pilot plant, the BSc chemists were better at that because they would think about the chemistry, the analytical techniques, and come up with better methods that we had to develop to answer specific questions. Mosey, go ahead, please. Moshe, I'm sorry.
Thank you, Andy. Thank you, Andy. I have two questions about the acidity and the significant difference between the limitation in US and the European standardization in the value of the high limit, and what is the reason for this significant difference, and what is the reason for acidity values of jet? I guess you hold some historical data about it. I hope so.
Unfortunately, I don't think I have. Now, can someone else, like Alistair, comment on this question? I'm not familiar with this. Moshe, we may need to discuss this offline so I can get a bit more information.
Happy to offer a few words to help. The lower acidity product tends to be military product, where this is a more stringent specification versus civil product. So that may relate to history and the long-term storage aspiration for typical military product, where it may be present for a long time in static storage, in which case a lower acidity would be to the benefit of the product and the tankage in which it's kept. But I would need to look in a literature reference to find the absolute reason. But that is the difference between military and civil.
Yes.
The civil fuel in D1655 permits the higher acidity limit compared with defence standard and MIL specifications. But I'll try and find a moment to look and answer your question by email. Good question though, and thank you, Andy, for the option there to come on the call.
And Alistair, maybe the second question about what possible sources for the acidity values? I guess it's some different reason for acidity. Something common, and some reasons it's very uncommon.
That's an interesting question. It may be acidic species present in the crude oil, because of course
Yes.
jet can be made from straight run distillation cut from crude oil, and there could be some organic acidic species in the kerosene fraction there. But again, let's check as aviators and find out if there's some guidance in the literature. An interesting aspect, because acidity, of course, TAN, total acidity number, importance to many products in the market.
Okay, I can add some general comment to Alistair's response. My understanding is that going back 50 plus years, there were somewhat more acidic crude oils, naphthenic crudes, in use by the industry, and that would tend to give slightly acidic products potentially. Today, there's a lot more hydrotreating, which eliminates trace acids, and there's very few crude oils in use today that are acidic. So I think it's probably a combination of changes in crude oil with fewer acidic crudes today, and the very much more severe treating that refiners use today that eliminates the oxygenated compounds. So I suspect those are two aspects contributing to changes long term, and that is over 50 plus years. The other point that's changed dramatically during my career is the storage time of fuels. Going back to the 60s, 70s, there was a lot of storage of fuel in the civil world. The military has always stored fuel for longer periods of time in order to have it instantly available. But when I first started in the industry, it was common to have much more storage throughout the entire distribution chain. And as accountants started to take over in management positions, they all wanted to cut down the operating capital. And having a tank full of fuel was operating capital that wasn't making any money for them. So a lot of companies started to reduce their fuel inventories to save money. They relied on just-in-time delivery. And the same thing occurred in the distribution chains, where we had refineries producing fuel, shipping them by pipeline to terminals. They all reduced their tankage. So many terminals have now become simply a bulge in the distribution pipeline. Many terminals that I'm familiar with barely have a week's worth of fuel. If there's an interruption in the pipeline, they start running short within a few days. So that's changed dramatically. And as Esther pointed out, it's the military that stores fuel for a long time. Very few customers store fuel for a long time. Remote mines, farming, maybe a bit of forestry, but most fuel, and my guess is 80 to 90% of fuel, is used within a couple of months of manufacture. So in the industry, fuel is being used. It has a very short standing time now. Okay. Any other comments before we move on?
We do have a question in the chat, Andy. It is, if you can't see that, I can read it.
Yes, please.
How is acidity measured in fuel? Just using normal pH meter, or do we need specific probes?
Okay, there are some test methods. Remember that acidity if you're going to talk about pH, pH requires an aqueous medium. So the test methods may require washing a sample with water and then testing the pH in the water extract. I'm not on top of these test methods. They haven't been significant for some time. But if you have a hydrocarbon matrix, you can stick a pH meter into it, you'll get a reading, but it's not a normal pH reading. You need an aqueous medium for a pH reading. Can anyone who's closer to this in the laboratory comment more fully?
In 1 second, I'll try to send the number of this. It's STM method, but it's a titration. It's in very specific and well described condition, including pumping of nitrogen gas, etc. I will send the number.
Okay, thank you.
This is Bob Morris. It's a titration with an alcoholic KOH usually, so it's a number expressed in volume of KOH per required to neutralize the system. So it's an arbitrary, I mean, it's not a direct pH measurement, it's an indirect measurement.
Thank you. Yes, I knew there was a twist in there, and I couldn't remember offhand exactly what it was. Thanks, Bob. Okay, keeping an eye on the time, moving along. I want to mention an aspect, limitations of test methods. Be aware that, just have to move this out of the way a bit. Most test methods were developed for petroleum-derived fuels produced in conventional refineries, wide boiling range hydrocarbons. That's how most of our test methods were developed over 100 years. These methods are not automatically suitable for new alternative fuels. We've got high boiling esters in biodiesel. We've got single compounds such as ethanol or ethyl levulinate. Some of the test methods that we've used for petroleum products may not be suitable for these products. For anyone in the gasoline world, if you're using ethanol gasoline blends, it's pretty tricky to perform a D86 distillation meeting all the requirements. If you have 10, 15% ethanol, when you're doing the distillation, in order to meet the distillation requirements, you've got to pump a lot of heat into it to boil off the ethanol. Once all the ethanol has boiled off, then you've got to cut the heat back instantly, or your test method distills off hydrocarbons too quickly, and you're not running a proper D86. So be careful as we get into more alternative fuels. Don't assume that our existing test methods are automatically suitable for the new fuel. If the new fuel is a wide boiling range hydrocarbon, then probably it will be appropriate. But if the new fuel is a chemically different entity, the existing test may not work properly. Another aspect where I've run into problems over the years is our conventional test methods may not be suitable for field samples with unusual or high concentration of contaminants. And flashpoint is one of the obvious test methods. People in the field think their diesel fuel has been contaminated with gasoline. And if you've got a trace of gasoline and diesel fuel, you can smell it, but nothing else has changed. Density is still the same. Flashpoint will be a bit lower. It's easy to throw diesel flashpoint off with a trace of gasoline. But if you have a sample with a significant amount of gasoline, like 5 or 10% gasoline, you can run a flashpoint in some instruments and it will not detect a flashpoint at room temperature. It'll go to its automatic starting point. The vapors above the sample are so rich that they don't ignite. So an automated instrument may miss a flashpoint at room temperature and report an erroneously high flashpoint for a sample of diesel fuel with significant gasoline contamination. So just a word of warning for those of you working in labs or associated with labs, don't assume that the test methods developed for petroleum products automatically work properly for field samples or for the new alternative fuels that are coming up along. Some of them will work perfectly well, others may not. Okay. Precision of test methods. Most properties, fortunately, are stable, and conventional statistics were developed for test methods for stable properties and have generally done a perfectly good job. Repeatability and reproducibility. This is following D6300 in North America, or the equivalent methods in Europe. Most test methods are for stable properties, and conventional statistics work perfectly well. However, transient, heterogeneous, and unstable properties, such as electrical conductivity, cleanliness, microbial contamination, H2S and heavy oils, conventional statistics do not apply to these properties. When you try to develop precision, particularly reproducibility, the properties themselves can have changed when different laboratories test samples at different locations over a period of time. Hence, in practice, precision of test methods for these properties has been developed by operators from different organizations at a single site and time. Those of you in Subcommittee J at ASTM DO2 are familiar with reproducibility single site. It's in the Subcommittee J operating procedures, and test methods for some of these properties that are transient or unstable are being tested. We follow the reproducibility requirements as much as possible. So operators from different organizations are brought to a single geographic location, and they do the testing all at one time. So hopefully, as much as we can arrange it, the property is stable over the few hours that it takes to perform testing by different operators using different instruments, operators from different companies, different organizations, using different instruments, but all testing the same samples as much as we can homogenize them at the same time. Let me just check what the next slide is. Okay. Discussion, your thoughts and reactions. Just going back for a moment to precision of these test methods for transient, heterogeneous, and unstable properties. We've been doing precision testing at a single location for 20 plus years, 25 years or more. And it's only fairly recently that we started acknowledging that normal statistics don't apply, because when you send samples to different locations, the property itself is changing. Microbial contamination, for instance, perfect example. Microbes can change in concentration or activity in a very short period of time. Okay, comments, questions about this whole subject of test methods, differences between test methods, various classifications of test methods. There was something else I was going to comment. Yes, since we have just a few moments, sampling for cleanliness. Most of our test methods state in the sampling section sample according to D4057. Yeah. The manual sampling omnibus standard or the equivalent in Europe. However, if you're sampling for cleanliness, you don't want a sample representative of the whole batch of fuel necessarily. What does cleanliness mean for a standing tank of fuel? Once a fuel has stood in a tank for 1 or 2 or 3 days, virtually all dirt and water will have separated to the bottom of the tank. And if you take a sample from the top of the batch, top of the tank, the middle of the tank, it will be very clean. As you withdraw product from the tank, initially it will be very clean. But at some point, if there's dirt and water on the bottom of the tank, it'll get stirred up either from adding fresh product to the tank or getting a low level of fuel in the tank, and you'll get very dirty fuel produced and delivered. So a comment, think carefully if you're looking at a cleanliness method for how do you define cleanliness in a standing tank of fuel. If there's no filtration system on the outlet, you can get very clean fuel and then very dirty fuel. However, if there is a filtration system on the outlet, then I suggest it's most appropriate to measure cleanliness of fuel after the filtration system to know how clean is the fuel being delivered from that tank, regardless of whether there's dirt on the bottom of the tank or not.
Andy,
Okay. We're about out of time. Any questions at this point?
Andy, just a comment. You kind of touched on this. Sampling is a whole thing unto itself, right?
Yes, absolutely.
Above ground tanks, you have diurnal heating, which tends to mix, but the U.S. Navy had experienced in underground tanks at Red Hill before they shut it down. And there we found the fuel stratified quite a bit from the bottom to the top. So sampling is, for some properties is a big deal.
Yes. And a number of the standard test methods haven't recognized this. And they just say, take a representative sample. And what I want people to start thinking about is what is an appropriate sample for cleanliness in different circumstances. It's one thing to have a batch of fuel coming through a pipeline where you can collect samples at the beginning, the middle, the end, test them, average the results, and you've got a result that's probably relevant to that batch of fuel because the fuel is mixed, moving, and homogeneous. But the moment it sits in a tank, what does cleanliness of fuel mean? If there's dirt and water on the bottom, if you can drain it all off and the fuel is indeed very clean with no dirt and water in the tank, great. You've got very clean fuel. But if there is dirt and water, you can suddenly get a slug of very dirty fuel.
So, Andy, I have added my email address to the chat. If anybody else has any questions or comments that they would like to, I'm happy to forward them over to Andy. Don't worry, I will not attempt to answer anything. I do want to be sensitive of everyone's time. I'm so grateful that everybody chose to join today. I have just a couple other things. Do you want to just say anything else before we wrap? Okay, you're good. Okay. All right. So thank you all so much once again. This was incredibly just so interesting to me, and I'm so grateful to see so many people have joined. We do have another, well, first let me just say really quickly before a lot of people are disconnecting, Thank you so much for joining. And I'd like to extend a huge thank you to Dr. Andy Pickard for his incredible insights and contributions to our industry. As you can see, they are impactful. Also, thank you to our host and chat box moderator, Enrico Rodrigueza, for his service to IASH as our first vice chair. We hope you found today's webinar helpful and are walking away with actionable ideas. If you have any questions or feedback, please do not hesitate to reach out to us. We'd love to hear from you. We also would like you to mark your calendars for our very next webinar Wednesday. It's going to be on March 12th. Our presenter, Madison Tomlinson of Lumen Ultra, will be leading us on an in-depth exploration of the latest industry guidance and research on microbial contamination in aviation fuels. So please use that QR code right now on your screen, and you can register for that webinar. That will also be on our website, and I'll be sure to send that out to everyone here as well so that you all get that too. I don't want you to miss out in case you had to hang up or don't have time. And then last but not least, we have our, this recording will be available to members on our website, or members only on our website. If you are not a member yet, please scan the QR code right now on your screen to join today. And thank you once again for being a part of this session. We look forward to seeing you next time. Have a wonderful day, and thank you, Andy.
Very good. Thank you.
Goodbye, everyone.
Thank you. Goodbye.
Oh, I'm in the front down there. With my wife.
Yes. Thank you, Andy, for a great presentation.
Okay.
It was wonderful.
I'm just laughing at the a note in the chat.
The 10 minutes, 5 minutes countdown?
No.
Oh.
The note from Melanie. Thank you, Andy. So much gets lost every time one of my elders retires. So I'm grateful that you share before you decide it's time to retire. Don't retire. Thank you, Melanie.
Oh, that's so good. Yes. I love it.
Bye, guys. Enjoy the rest of your day.
Thank you, Doug.
Thanks, Doug.
Uh-oh, it looks like someone came up late. I bet they joined. We'll let her know. Oh.
Okay.
All right. Well, thank you again. I will, hopefully that whole thing recorded. I don't know what happened. I set it to automatically, so I don't know why it stopped, but then I was able to restart it. So we'll see.
Okay. I'm perfectly happy with you posting or sharing the presentation itself, if you want to do that.
Thank you. Thank you. That's wonderful.
Okay.
All right. Thank you, Andy.
For everything that you've done to make this work out smoothly.
Wonderful. I'm glad to hear it. Thanks so much.
Hunter.
Thank you both. Take care.
Okay.
All right.
Signing off.
Bye-bye.